Alright, so this is going to be another stab at section 2.2. I did section 2.2, must be 3 months ago. I finally got around to watching the video, and it was really pretty wretched, so I figured I would do it again. And hopefully I do a bit better this time. It was bizarre. Like, in that video, I would say 18x squared, and then I would write this and not write the 8, or I'd say 30x minus 5, and I wrote 33x minus 5. So it was just, there was so much of that going on in the video. I don't really know what was going on, but I must have been more tired than I needed to be to do a video. So hopefully this is a little bit better. After getting to watch some videos, I see that some of my calculator work just isn't that legible. Oh gosh, to redo every video where the calculator wasn't completely legible would be a monstrous undertaking. Mostly you can read the calculator stuff. Sometimes you have to really kind of pause the screen to look at it. If there's some calculator work that you just need to see and you just can't see, tell me and I'll do that video over. So in section 2.1, we learned one strategy for taking the derivative of simple problems without having to use limits. And in section 2.2, we're going to learn 2 more rules for taking derivatives. The first of the 2 rules we're going to learn for taking derivatives is handy when a problem has multiplication. My markers are pretty dead. I haven't used them for a while. If a problem has multiplication in it, in section 2.1, we learned that you can get rid of the multiplication by foiling or doing whatever distributive property that was needed to get rid of the multiplication, and then you could revert to using the power rule. The product rule allows us to take derivatives of problems that have multiplication that we don't care to get rid of the multiplication, or it's kind of too impossible or too hard to get rid of the multiplication. So it's used to find derivatives in problems that contain multiplication. Usually that multiplication is in the form of a parentheses or 2 parentheses. It doesn't have to be, but that generally is the case. When I watch my videos, I've watched all of chapter 1 and up to here in chapter 2, I almost found it kind of annoying when I started, I'd say something and I'd write something because it takes so long. But usually if I write something, there's a reason I'm writing it. It's because it's an important concept. And the product rule, the statement of the product rule looks complicated. So this is the statement of the product rule. And it looks more complicated than it's is. So don't let this intimidate you. If you don't completely understand the notation for the product rule, that's not going to keep you from doing the product rule. So the product rule says if a function is the product of 2 functions, so if the function h of x is the product of a function f of x and g of x, then the derivative of h of x, h prime of x, can be found by taking the derivative of the f function and multiply that derivative by the g function, how it was given, and then add to it the derivative of the g function times the f function, how it was given in the original problem. That's very complicated. Like I said, generally there's parentheses in multiplication problems, and what's inside each of the parentheses is referred to as a factor. So generally a product, the things that are being multiplied are factors. And so if we said h of x, some function, is factor 1, or something in a parentheses, times factor 2, another object likely in a parentheses, we can say the derivative h prime of x equals the derivative of factor 1 times factor 2 how it was given, plus the derivative of factor 2 times factor 1 how it was presented in the problem. And even that might be, a little too sophisticated in terms of, you might not understand what that means. But both of these are nice statements of the product rule. It's a technique for finding a derivative when there's multiplication in a problem. We learned that if a problem has multiplication, you can get rid of the multiplication and apply the power rule. That will still apply in this section. Those techniques that we learned in section 2.1 will still apply, but this will just be another technique that will work. And sometimes it's going to be awkward or impossible to do the multiplication, so this is a rule we have to learn how to do. So let me just jump into doing problems from the section to kind of illustrate the rule, the product rule. So problems 1 through 14 specifically say use the product rule. So I'm going to use the product rule. However, problems 1 through 14, most of them are set up so you could also do the power rule. And for one of the problems, maybe problem 2, I'll do it both ways. So first, I'm going to solve problem 2 using the product rule. Notice to the left of the equal sign, there isn't an h of x. There just needs to be a y or some function symbol to the left of the equal sign. And it doesn't matter if it's a y or h of x, f of x, or a g of x. When I go to take the derivative, on the left side, I'm going to write something that represents the derivative. So I'm going to write y prime. And then I'm going to write in equals. And then I'm going to write in words what I need to do. To use the product rule, I need to take the derivative of the first factor, and that's going to be asking me to take the derivative of 3x minus 4. And then I'm going to multiply that by the second factor unchanged. And the second factor is 5x minus 8. Then I'm going to put a plus sign. The formula has a plus sign in it. And after the plus sign, I put the derivative of the second factor. The second factor is 5x minus 8. And I multiply that derivative by the first factor, and the first factor is 3x minus 4. Haven't taken any of the derivatives that I need to take yet, so I'm not ready to simplify this. So the product rule involves taking the derivative of each factor, multiplying it by the other factor unchanged, and then throwing a plus sign between those. So to get this derivative, I'm going to take the derivative of each of the things that I circled in that orange box. So I need to take the derivative of 3x minus 4, and I'm going to leave that to the left of the 5x plus 8. To do the derivative of 3x minus 4, first I'll do the derivative of 3x. 3x is really 3x to the first. To do its derivative, I'll take the exponent 1, multiply it by the coefficient 3, and I'll lower the exponent by 1. So the derivative of 3x to the first is going to be 1 times 3, which is 3, x to the 0 power. Anything to the 0 power is 1, so that's going to be 3 times 1, which is 3. So the derivative of the 3x piece is 3. And the derivative of the minus 4, because it's a constant, it doesn't have an x, its derivative is 0. I'm not going to put that 0 in here, but I could have put minus 0 after the 3, but it's not necessary. So that's the derivative of 3x minus 4 times the second factor. Look what I just did. I changed the 5x minus 8 to a 5x plus 8. I did that so much in the video that I'm fixing that I hope I don't repeat that. I just don't know what my deal is here. So that 5x minus 8 was supposed to say 5x minus 8. And now I'm going to put a plus sign. And after the plus sign, the thing that doesn't change is the 3x minus 4. What does change is this. I need to take the derivative of 5x minus 8. The derivative of 5x is real similar to the derivative of 3x. To do the derivative of 5x, you have to think of 5x as 5x to the first. You multiply the exponent by the coefficient, and you get 1 times 5. You lower the exponent by 1. So that's going to give me 1 times 5 is 5. and then x, the exponent of the x is going to be 0. Anything to the 0 power is 1, so x to the 0 power is 1. That's going to be 5 times 1, which is 5. So inside the second parentheses, there's two terms. I'm going to do the terms derivative separately. The derivative of 5x is 5. And the derivative of minus 8, because it doesn't have an x, it's a constant, it has a derivative of 0. So that's the derivative of 5x minus 8. I'm leaving the 3x minus 4. Now I've successfully computed the derivative. I just want to simplify it. And generally by simplifying, you're going to clear parentheses and combine like terms. The first parentheses I'm going to clear by going 3 times 5x, and I'll get 15x. And I'll do 3 times minus 8, not the silly plus 8 that I put, and I'll get plus 24. Then I'm going to bring the plus sign down and clear the second parentheses by going 5 times 3x is plus 15x, and 5 times minus 4 is minus 20. Now I'm going to combine the like terms. I'm going to add this 15x plus that 15x, and 15 plus 15 is 30. And when you're adding, the exponents and the x's don't change. So I'm going to get a 30x. And then the numbers are both negative. And when that's the case, you add the numbers and keep them negative. And I'm going to get minus 44, because 24 plus 20 is 44. So I'm done with problem 2. There isn't anything else I have to do, but I could have done this. I could have avoided the product rule and still found the derivative of the function in number 2. And how you avoid the product rule is you clear the multiplication before you do the derivative. So I could have taken the problem and FOILed it. I could have done firsts are 3x times 5x and got 15x squared. Outers are 3x times minus 8, which is minus 24x. Inners are minus 4 times 5x, which is minus 20x. Lasts are minus 4 times minus 8, which is a plus 32. I could have combined the minus 24 and the minus 20x. I've not taken a derivative yet because I haven't multiplied any exponents by coefficients. What I've done is I've rewritten the problem so that I wouldn't have to use the product rule. So the product rule is you have to use the product rule if you want to take the derivative without clearing the multiplication. If it's easy to clear the multiplication, then you can clear the multiplication and use the power rule to find the derivative. So now I can use the power rule. How the problem was originally written, I couldn't use the power rule to find the derivative because the power rule specifically can't have parentheses with multiplication. So now I'm going to write y prime, and for the first piece I'm going to multiply the 2 times the 15, and I'm going to lower the exponent by 1. The exponent was 2. 2 minus 1 is 1. The second piece really has an exponent of 1, so I'm going to go 1 times minus 44 and get minus 44, because 1 times minus 44 is minus 44. Lower the exponent by 1 and get x to the 0. The last piece, the plus 32, doesn't have an x, so it has a derivative of 0. Now I'm going to do this multiplication and write the problem a little bit nicer. And it's going to give me y prime. 2 times 15 is 30. I don't need to write the exponent of 1 on the x. And the last piece, the 44x to the 0, since x to the 0 is 1, that's really minus 44 times 1, which is minus 44. And you'll see that clearing the parentheses and using the power rule gives you the same derivative as using the product rule. In most of the problems between 1 and 14, it's probably easier to use clear the multiplication and use the power rule. But at some point, it's not going to be easier to clear the parentheses, and the product rule is going to be the easier way to go. So for each of the problems between 1 and 14, I'm just going to use the power rule, the product rule, should I say, because it's just going to make it easier when we get a little bit deeper into the chapter. As I'm going through the problems, I'm going to need the answers to the first couple problems when I do problems 33 through 42. So real quickly, I'm going to flash up problems 33 and 42 on the screen, and the first step in doing problem 34 and the first step in doing problem 33 is going to be to find the derivative of the function that's given to us. In problem 34, the function that's given to me, 3x minus 4 times 5x minus 8, is this function. I'm going to need to know its derivative, and I know the derivative of 3x minus 4 times 5x minus 8 is 30x minus 44. I'm just going to write that down and keep it handy for when I do problems 34. When you do problem 33, you're going to need to know the derivative to problem 1. So if you've just computed the derivative to problem 1, off to the side somewhere is where it's handy, write down that derivative because you're going to need it when you do problem 33. All right, that's all I want to say about problem 2. Hopefully you gave problem 1 a shot. And I'm going to move on to do problem 3 and 4. I'm going to do problem 4. You're going to do problem 3. And again, I'm going to use the product rule to do this one. And when I use the product rule, I have to say y prime, or I could say dy dx if I care to. And the derivative is found by doing two computations. First, I want to take the derivative of the first factor. So I want to find the derivative of x minus 5, and I'm going to multiply that by the 3x squared plus 7, just how it was given to me. Then I'll put a plus sign down, and I'll take the derivative of the 3x squared plus 7. And what I'm going to multiply by is the x minus 5, how it was given to me. So the product rule involves taking the derivative of each factor, multiplying it by the other factor unchanged, and put a plus sign between that computation. So on the left side, I can write dy dx. dy dx and y prime are interchangeable. Usually I write y prime unless there's just something that notation is more useful for. And that turns out to be in chapter 5 that notation is useful, the dy dx. But for y prime is fine. So you can interchange dy dx and y prime all the time. So to get to my next line, I need to take the derivative of x minus 5. To do the derivative of x minus 5, the derivative of the minus 5, because it doesn't have an x, is 0. I don't need to worry about it. The derivative of the x, I bring the 1 out front, and I'm going to get a 1 times x. I'm going to lower the exponent to 1. You get 1 times x to the 0 power. X to the 0 power is 1, so that's going to be 1 times 1, which is 1. So for this derivative, I'm going to replace it with the number 1. It doesn't have to be in a parentheses, but it can be. And I'm going to leave the 3x squared plus 7 right where it was at. Bring down that plus sign. To the next piece, I need to take the derivative of 3x squared plus 7. When you're doing the derivative of 3x squared plus 7, the derivative of 7 is 0 because it's a constant, it doesn't have an x. To do this derivative, I go 2 times 3 is 6, and I lower the exponent from 2 to 1. So the derivative of this is 6x to the first plus 0. I'm not going to write the exponent of 1, I'm just going to write 6x. Doesn't matter if it's in a parentheses or not at this point, because it's just a monomial. And I leave the x minus 5 just how it was. Now I'm going to clear the parentheses. The first parentheses, 1 times anything, is itself. So I'm just going to write 3x squared plus 7 back again. For the second parentheses, I go 6x times x, which is 6x squared. And 6x times minus 5 gives me a minus 30x. The last thing I'm going to do is combine like terms. I'm going to be left with a trinomial that may factor. Generally, I don't take the time to factor a trinomial unless I'm doing something with the derivative. And we'll do stuff with the derivatives, but not with this problem, so I'm not going to worry about factoring it. I think that's prime anyways, but generally if the derivative comes out to be a trinomial, if all you're asked to do is find the derivative, you just find the derivative and stop. As I look at the problems in the 33 through 42, this problem doesn't come up again, nor does problem 3, so we don't need to take note of those derivatives. So I'm done with problem 4. I could have done it using the power rule. I could have FOILed the parentheses and then take the derivative of each term. But that's, again, my videos are so long as they are, I'm not going to do that for this problem. So I'm just hoping that my answer is right. So that derivative is 1. I kept that sign right. That derivative is 6x. Looks perfect. I hopefully didn't mess up at all here. When I mess up, I redo videos, and that's not fun. So for 6, I'm going to use the product rule because there's a multiplication. I'm going to write f prime of x. And what I need to do is I need to take the derivative of 3x squared plus 6x minus 2, and I need to multiply that by 4x plus 1. I'm going to put a plus sign, and then I need to take the derivative of 4x plus 1 and multiply that by 3x squared plus 6x minus 2. So I'll do the derivatives a little bit faster here. The derivative of 3x squared plus 6x minus 2, I do the derivative of each piece separately. For the 3x squared, I multiply the 2 times the 3 and get a 6. Lower the exponent to x to the first. I don't need to write that 1. For the 6x, has an exponent of 1 that's not written but implied. I go 1 times 6 is positive 6. The exponent turns to x to the 0, makes that x turn into a 1. The derivative of the minus 2 is 0, so I don't need to write its derivative down because it's 0. And I'm going to leave the 4x plus 1 in the plus sign. So I've taken this derivative, left the 4x plus 1 unchanged, brought the plus sign down. Now I'm going to take that derivative. The derivative of 4x, which is really 4x to the first, plus 1. I go 1 times 4 is 4. Lower the exponent to 0. The derivative of 1 is 0. This is going to leave me with 4 times 1 plus 0. That whole thing comes out to be 4. The derivative of 4x to the first is 4. The derivative of 1 is 0. So the derivative of 4x plus 1 is 4. And I'm going to leave the 3x squared plus 6x minus 2 just how it is. This looks factored, but it's really not a good factoring. So I'm going to clear all the parentheses. Generally, when you use the product rule, after you do the two derivatives, you clear the parentheses and combine like terms. So I'm going to do that now. First parentheses I have to FOIL. So first are 6x times 4x, which are 24x squared. And then 6x times 1 for the outers, which is plus 6x. The inners are 6 times 4x, which is plus 24x. The last are 6 times 1, which is plus 6. Got the first junk cleaned up. I'm going to bring this plus sign down. I'm going to clear the second parentheses by going 4 times 3x squared and getting a 12x squared. Then a 4 times a 6x, and I'll get a 24x. And then a 4 times a minus 2, which is a minus 8. And now I need to combine like terms. So I'm going to make the 24x squared and the 12x squared combine to a single term. And then the plus 6x plus 24x plus 24x, this, and that combined. And then the 6 minus 8, the plus 6 and the minus 8. So there's kind of 3 groups of terms that need to be combined. So this is going to give me f prime of x equals 36x squared for those. And then 24 plus 6 is 30, plus another 24 is 54. So plus 54x, and 6 minus 8 is minus 2. If you want to factor out a common factor of 2, you certainly can do that. Generally, when I'm asked to just take a derivative and I'm not doing anything with that derivative, I usually don't even pull out common factors. All right, so give number 5 a go, and I don't see that I need problems 5 or 6 when I do the problems at the bottom of the section, so we can kind of ignore the answer. We won't use it for anything else. We don't need to write it down and remember it. All right, 7 and 8 we're going to need. When I do problem 35 and 36, we need 7 and 8. So these derivatives, I'm going to take a time to write down. So I'm going to use that product rule again. So I'm going to write g prime of t. And the first thing I need to do is I need to take the derivative of 3t squared plus 5t. And I'm going to multiply that by the 2t plus 1 just how it was given. Then bring a plus sign down. And then I'm going to do the derivative of 2t plus 1. And I'm going to multiply that down by the 3t squared plus 5t just how it was given. So the product rule always requires you to take two derivatives. So I'm going to do this derivative and this derivative. This first derivative, I do the derivative of 3t squared. I multiply the 2 times the 3 and get 6. I lower the exponent and get 6t to the first. The derivative of 5t is plus 5. So I'm going to start doing some derivatives in my head just to speed up the process. I think you could do the derivatives that I'm doing in my head easily in your head, hopefully by this point. So this is the first derivative of the first parentheses times the second parentheses unchanged. Now I'm going to take the derivative of 2t plus 1. The plus 1 has a derivative of 0. 2t has a derivative of 2. And I multiply that by 3t squared plus 5t unchanged. Alright, so now I'm going to get g prime of t equals to, I'm going to clear this parentheses and FOIL. First, 6t times 2t is 12t squared. Outers, 6t times 1 is plus 6t. Inners, 5 times 2t is plus 10t. Last, 5 times 1 is plus 5. Clear the next parentheses. 2 times 3t squared is 6t squared. 2 times 5t is plus 10t. Now I'm going to combine like terms. The like terms I'm going to combine are the 12t squared and the 6t squared. When I combine those, I get an 18t squared. And then 6t plus 10t plus 10t give me a 26t. And lastly, I'm going to bring down the plus 5. There's nothing to combine. There's a shot that that actually factors. I don't think it does, but it could actually factor. So that derivative I'm going to need when I do problem 36. So I'm going to write this right down on my problem 36. So when I get to that off in the future, I don't need to recalculate that derivative. And again, when you go to do problem 35, you're going to need the derivative from problem 7. So you might as well write that down because it's going to make your work less when you actually get to that. All right, keep going here. Hopefully you saw everything you needed to see. All right, 9 and 10. It looks like I need 9 and 10 when I do 37 and 38. So I'm going to take the answer from number 10 and write it down under number 38. So it's another product rule. They're not two parentheses, but there's two multiplications. This is 4x cubed is the first factor, 3x squared plus 7x minus 5 is the second factor. I'm going to write y prime because I'm taking the derivative. And what I need to do is I need to take the derivative of 4x cubed. I need to multiply that by the 3x squared plus 7x minus 5 unchanged. Bring a plus sign down. And then I need to take the derivative of 3x squared plus 7x minus 5, and I'll multiply that by the 4x cubed unchanged. The derivative of 4x cubed, I just go 3 times 4 is 12. I lower the exponent by 1 to 2. So I'm going to get this side. I'm going to have a 12x squared in place of the derivative of 4x cubed because you're just multiplying the exponents by the coefficients, lowering the exponent by 1. And then I'm going to multiply that by 3x squared plus 7x minus 5. And then for this parentheses, I need its derivative. For the 3x squared, I go 2 times 3 is 6. I lower the first. The derivative of 7x is just 7. So I just had a glitch here, so let me make sure you heard what I said. For this derivative, I go 2 times 3 is 6. I lower the exponent from 2 to 1. I don't really need to write the exponent when it's a 1. For this derivative, there's an implied exponent of 1. You multiply the 1 times 7, you get 7. You lower the exponent, and you get x to the 0, which is 1. You don't need to write that. And then the derivative of the minus 5, because it's a constant without an x, has a derivative of 0. So now I've taken the derivatives that I need. It's just a matter of simplifying. So for the first simplifying, I need to multiply 12x squared by each thing in the parentheses, that's each term in the parentheses that's next to it. So I'm going to write y prime equals 36, add the exponents on the x's, 36x to the fourth, and then 12 times 7 is 84. When you multiply an x squared times an x to the first, you add the exponents and you get an x cubed. And then 12 times minus 5 is minus 16. I leave that x squared, so I get minus 60x squared. For this multiplication, I have to go 6x times 4x cubed. 6 times 4 is 24. And on the x's, I add the exponents. X to the first and x cubed gives me x to the fourth. And then I do 7 times 4x cubed. You multiply the 7 and the 4 and get a positive 28. And the x cubed has to stay there unchanged. So now for like terms, I'm going to combine the 36x to the fourth and the 24x to the fourth. When you're adding, the exponents don't change. That's going to give me 60x to the fourth. I need to combine the 84x cubed plus 28x cubed. And 84 and 28, 12, that's 112, I believe. X cubed. And then this minus 60x squared has nothing to combine with. It's just going to be part of my answer. And again, generally, when I'm asked to compute a derivative, I don't factor it unless I'm trying to do more with the derivative. I'm going to make sure that I actually did 24 plus, or 84 plus 28 right, because if I did it wrong, then it's forever wrong. So I did it correctly. Generally, if the derivative even comes out to a trinomial, if there's common factors, I don't have a big urge to factor these things. But if we're doing something more with the derivative, if there's more words to the problem than find the derivative, if it's do something, find the equation of a tangent line, or find the slope of a tangent line, or find horizontal tangents. Usually if I see words about tangents or maximums or minimums, I have to start doing more with the derivative. So I wrote down on my problem 38 the answer to problem 10, because I'm going to need it. So make sure when you do problem 9 that you keep that answer handy. You're going to need it when you do problem 37. So just a few more problems in this part of the video, two, and then we'll have a part 2 and a part 3 for this. Alright, so this is a product rule. This seems really silly to use the product rule. It would be so easy to multiply this out. But I'm going to use the product rule because the instructions tell me to, and I need practice with it. So the first factor I need to take its derivative of is 7x squared. And I'm going to multiply that by 6x unchanged. And then I'm going to take the derivative of 6x. I'm going to multiply that by 7x squared unchanged. This is the worst way possible to do this derivative, but I'm going to do it just because the instructions tell me to. The derivative of 7x squared, I go 2 times 7 and get 14. I lower the x by 1 and get a 14x. I leave the 6x unchanged, bring down the plus sign. The derivative of 6x, it has an exponent of 1 that's implied. You go 1 times 6 is 6. Lower the exponent, you get x to the 0. 6x to the 0 is 6 times 1, which is 6. So that's going to give me, using the product rule, because that's what I was asked to do, the two pieces. And now I'm going to simplify those. So I'm going to get f prime of x is 6 times 14, which is 84, x times x, which is x squared, plus 6 times 7x squared is 42x squared. And then I'm going to add the 84x squared and the 42x squared. 84 and 42, I believe, add up to 126. And when you're adding, the exponents don't change. So this is the derivative using the product rule. All of this is the derivative of f of x using the product rule. In general, on a test, I won't tell you which strategy to use to find a derivative. And we're going to learn a handful of strategies. It would have been better to do this. I could have said f of x, and I could have done the multiplication. I could have done the multiplication, did 7 times 6, which is 42. Add the exponents on the x's. 2 times 1, 2 plus 1 is 3. And then I could have used the power rule. I could have did f prime of x equals 3 times 42, and then lower the exponent by 1, and you'll get f prime of x equals 126x squared. So clearing the parentheses so that you get rid of the multiplication and using the product rule is usually better than using the product rule. But all of these problems, I use the product rule just because there are going to be times when it's hard to do the multiplication or the multiplication is messy. So I want to get used to doing the product rule with easy problems before we jump into hard problems. But clearing the parentheses and taking the derivative using the power rule will always give you the same answer as the product rule. So you don't always have to use the product rule. And it's going to be up to you, especially when we do a test, when you're asked to do a derivative of something. If it has a multiplication in it, if you want to clear the multiplication and use the power rule, it might be easier than taking the derivative using the product rule. All right, last one for this part. Another one where it would probably be easier to use the multiply out and use the product rule, power rule, but I'm going to use the product rule. I'm going to write y prime, and I need to do the derivative of 2x to the minus 5 times the 5x minus 8 unchanged, plus the derivative of the 5x minus 8 times the 2x minus 5 unchanged. So for this derivative, I go minus 5 times 2 is minus 10. And when you lower the exponent by 1, you take the exponent of minus 5 and you subtract 1, you'll get minus 6, because minus 5 minus 1 is minus 6. So I'm going to get 10x to the negative 6 times the 5x minus 8. Ugh. Second piece, the derivative of 5x is just 5. The derivative of minus 8 is 0. So I've taken the derivative. Now I'm going to clear the parentheses. I'm going to multiply minus 10x to the negative 6 times 5x. And when you're multiplying these, you add the exponents on the letters, you multiply the numbers. So minus 10 times positive 5 is minus 50. X to the negative 6 and x to the positive 1, you add the exponents. Negative 6 plus 1 is negative 5. Second multiplication, I multiply the negative 10 times negative 8 and get positive 80. And for that second multiplication, I leave my x around. Probably would be nice if I kept writing the y prime because I've actually taken the derivative. Next piece, I just multiply the 5 and the 2 and get a 10 and leave the x to the negative 5. These terms can certainly be combined because they have the same variables with the same exponents. The numbers in front of them have opposite signs, so I subtract the numbers, but I don't change the letter. So this piece is going to give me a minus 40 x to the negative 5 plus 80 x to the negative 6. I don't need this derivative. You could certainly factor out a common factor. I haven't done any factoring of common factors, so I'm going to hold off on that. But you can, actually both terms have an x. There's a way to factor out with negative exponents that we might get into a little bit later in the class, but not on the beginning of learning the product rule. And there's a common factor. But I haven't factored any of the first 14 problems. Doesn't feel like it's a good time to start. It would feel inconsistent if I did that. All right, so that's the first of 3 parts that we're going to do. And then let me pause the video right now. And the next thing we'll do is we'll learn how to use the quotient rule, which is finding the derivatives in problems that have division.